Hi, I'm Dan from Maptek, and today we're going to make hazard cones around some planned drill holes. So today we're going to focus on the Drillhole Planning Reporting tool in Vulcan. And while reporting may not sound super exciting, this is actually a really powerful tool to help identify potential breakthroughs or hazards with your potential drill holes. So I'm starting off here. I've got a drill program that I've designed using the Create Drillholes tool. And you'll notice I've applied deviation to these holes using deviation rates that I calculated from historic drilling using the deviation calculation manager. So one of the biggest hazards in drilling, especially underground, is potential interactions with existing development, stopes, voids, drill holes, or even services. And historically, checking for these interactions was a fairly manual process. So we made this tool to create an automated and repeatable way for you to do this quickly in Vulcan. So in this case, I've got some nearby development, and I've also got some ungraded drill holes that I want to check to see if any of my planned holes are going to be potentially problematic. So the first thing we're going to do is we're going to open the Geology Drillhole Planning Reporting tool. And first thing you'll notice is that it's hidden everything that I currently had in the view. This is intentional because it just sort of makes it a bit easier to select what you want as it appears, because it'll sort of filter it when you're picking design data or triangulations. So just gets rid of a bit of the noise for you. So we'll just create a spec file and a scenario. Now, before we start, it's important to know this reporting tool can actually be thought of as two separate tools. So we've got the Breakthrough Hazards Report tool and the Intersection Report tool, and they kind of do different but similar things. You can run them both together, or you can run them each independently. So in this case, I'm going to turn off the intersection report and we'll start with the breakthrough hazard report. But initially we've got to select some drill holes. And these are the drill holes that I want to build hazard cones around and then test if anything intersects with those hazard cones. I've got two options for where my data can come from here. Now you can pick design data. So if you've made drill holes, again, if you use the Create Drillholes tool, or if you made them manually and you've got them as CAD strings in a design database layer, you can pick them here. So you can sort of pick your design database and sort of go and pick the layer. You can also pick using the screen pick. So in this case, you'll see to bring everything back up that's design data, and I can go and pick my layer for my drill holes that I want to use. I could also, if I wanted, select my drill holes that I want to build the hazard cones around from an existing drill hole database. So if you use the option in the Create Drillholes tool to save your drill holes to an existing database or to a new database, you can pick that here, and it can be an existing drill hole database, or you can use a DSF file that links to an ODBC drill hole database. So you could sort of just come in and pick your planning drill holes, and you could use a selection file, for example, to filter the holes for that particular program if you wanted. In this case, I'm going to use the CAD strings that I already had, or the drill holes that I made. So next, in this Breakthrough Hazard Report panel, this is where we define the dimensions that we want to use to build the hazard cones around the drill holes. So obviously I can come in and manually type whatever thresholds and hazard widths I want in here, but I'm going to load one that I made earlier. So in this case, we're just defining how big our cone's going to get at what depth down hole. Now, you've got this option to kind of load one, and you can save it out. So if you define a particular spec file that you then want to use as the standard for site, you can save it out to wherever you like. You can browse to whatever folder. So you could have it stored on a network directory, and then everyone uses that same spec file for generating these cones. So then the inputs panel is everything that we want to test to see if they intersect the hazard cones. So this is where we can use triangulations for stopes, for existing development, for planned development, whatever we like. So in this case, for me, I've got just a single triangulation loaded on screen. That's a planned development drive. You can use design data. So if you've got as-built strings, or if you've got design strings or service holes in strings, whatever you like, you can kind of select from there. Also, we can use Drillhole databases. So again, these can be a design database or an ODBC database where you can check, for example, against ungraded holes. Again, you can use a selection file if you like, but I'm just going to use all the holes in this case. Next, we have the outputs panel. So at the top, we can define an exclusion distance from the collar. So where this can be useful is if you've put an input triangulation here that might be like a total as built for the whole mine, or it might be, for a whole level, for example. But if you're actually drilling from that level as well, you might want to put an exclusion distance so that you don't get an intersection point reported at the collar of each hole. So what this will do is it basically says, all right, anything between 0 and 5 meters down hole, if there's an intersection, it's not going to get reported. You've then got the option to create the triangulation within the exclusion distance. So that's just a visual thing. It just means otherwise, if you don't have that turned on, you're going to have a gap from the collar to whatever depth down hole you define as your exclusion distance. You've got two options for the kind of output shape that we get. You can either have a cone or you can have discs. And there's a really good image in the help that I'll pull up and sort of show you the difference of what they look like with the same thresholds. You got the option to append a half sphere at the bottom of the triangulation. So this will essentially give you a buffer at the end of hole for your drill hole. You also have the option to create individual triangulations for each of your depth thresholds that you've defined. And if you do that, you've got the option to create separate subdirectories for each drill hole. So this can be quite handy because if you've got long holes, lots of depth thresholds, it's going to keep it neat and organized for you in separate subdirectories rather than everything just getting jammed into a single folder, which can get quite messy. And we have the option to choose the colors for what we want. So the hazard triangulation color is basically any hazard cone that gets created and flagged as having an intersection with any of my input data, that's going to get colored red. Any of the other ones that don't have any intersections, they're going to get colored green. Now, if you're using the create individual triangulations for each threshold, you can use a color scheme and you can basically color against any of these calculated attributes. So this can be useful if you want to hone in really quickly on areas that might have intersections within a certain distance from the drill trace itself. In this case though, I'm just going to create a single hazard cone for the hole, do it in cones. You've also got the option here to save the intersected hazard inputs to a design database layer. So that's going to save anything from this design database and the drilling database objects. It's going to save anything that we've entered in here and it's been flagged with an intersection. It's going to save a copy of that to this layer. So I'll give it a name. I'll say same as my thing, and I'll call it breakthrough hazards. So that's just, it means it gives us a quick reference layer later if we want to see what intersection objects were problematic without having to load everything back up again. Once we've set everything there, we can use this preview panel to get a visual indicator on screen of problematic drill holes. Now this is optional, you don't have to run the preview, but I find it really handy to be able to just declutter and have a quick interrogation visually of my holes that I need to maybe look into. So if I run preview, you can see initially everything's back on screen. We've got all our drill cones and you see they obviously follow the deviated trace of the hole. And we've got some red holes are the ones that have intersected with our inputs that we used. So in this grid, you get a list of all the holes and you get a report of any of the drill holes that have intersected something. So it's just a condensed version at this stage. We're just basically getting the closest point to the drill trace for any of these hazard objects. So we get a much more detailed breakdown in the report, which we'll look at in a minute. But this is just giving you a grid of a summary to sort of say these are the holes that we've detected problems with. So if I want to declutter this a bit, I can use this checkbox here to only show the hazard triangulations with intersections. So all these green ones will suddenly disappear, right? And then we've just left with the ones that have intersection issues. You've also got another option to only show the inputs with intersections. What that's going to do is get rid of any of the inputs. And then when I select a drill hole in the grid, you can see it changes to then just show me the input objects that I wanted to test that intersect my hazard cone for each of the drill holes. So it's sort of a nice quick way to go through and see what things intersect with those drill holes. You've also got the option you can sort of hide unselected hazard triangulations. So again, in that case, it sort of just hides more of the noise. Right? So if you've got lots of drill holes bunched close together, that can be really handy because then it's gonna filter it down so you just see the hazard cone that you're interested in. You can also highlight selected drill holes, which is just gonna light it up on screen. Once I'm happy with this, then I can save and run, and it's gonna actually generate everything. To this point, these are just temporary objects that are used for the preview. So if you hit cancel now, nothing's going to get created. But I save and run, it's going to save my spec file and generate all my files. So you can see everything's back. All right, everything's back on screen. So if I remove everything now, so the first thing we got was this breakthrough hazards. So we just had 2 drill holes, obviously that intersected previously. And if we have a look at those, you can see you get information about the drill hole name that came from and where the original data came from. So that was obviously from a drill hole database, right? You'll notice we've also got this triangulation subdirectory that's been created. This is where all our hazard cones have been saved. So I can sort of load all of those if I like. Also remove them. But what we actually have, if we open up our folder, you can see obviously we've got the triangulation subdirectory, but we've also got another subdirectory that's been created. Now in here, this is where we've got some nice things. Firstly, we've got our CSV report. So if we open that, this is the definitive list of all the intersections and issues that we had with our drill holes or with our hazard cones. So there's an entry for every hazard object for each drill hole. So if one drill hole has multiple hazard objects that intersected its drill cone, it'll have a row for each of those hazard objects. So we get the intersection location of where this hazard intersected the hazard cone. We get the distance then of how close that intersection is to the drill trace. You also get the depth down hole that intersection occurred. And if you've got multiple intersections for that hazard object for that drill hole, you get extra columns added to kind of show you all of those intersections. Some other handy things we actually got in our folder is we get these selection files. So we have a drill hole selection file, which basically if we open it, has a list of the drill holes that had hazards reported with them. We also have a drill holes with interactions triangulation selection file. So I can just drag that in screen and that's going to load the hazard cone triangulations from my subdirectory that had interactions with them. All right. And when we're talking about this closest point to the hole, what that means is if we've got these couple of holes here, for example, this hole down the bottom, you've got an existing drill hole which intersects this hazard cone at those 2 points. But the drill trace is running up the middle, so you've actually got a point inside the hazard cone for this particular object, which is closer to that drill trace. So that's what we're getting here is the distance between the closest point on this section of hazard object inside the cone to the actual drill hole trace itself. So that's kind of the one that's sort of really important. You want to sort of see how close it's getting to your trace. Similarly, we've also got another selection file that gets created in here. And this is any of the input triangulations from the input panel that were flagged as intersecting our drill holes. So obviously I drag that in. I've got my planned development drive, which obviously intersects a couple of my drill holes. All right. Next, I'm going to remove everything. Next, we're going to take a look at the intersection reporting tool. Now I'm going to cheat. I'm going to use my existing spec and I'm going to save it as, and I'm going to call this one intersections, as it means I don't have to reselect my drill holes. So I'm going to turn off the breakthrough hazards report. I'm going to turn on the intersection report. So this tool is really useful for, as an example, if you've got some junior geologists that are just started up and learning the deposit, and you want to be able to provide them with a bit of information of where downhole to expect intersections with certain domains, for example. So we can browse and we can pick the triangulations that we want. So I'm going to grab my TQ1 and my TQ2 domain triangulations. And then we've got options where we can save the intersections as points to a layer in a design database. So I will call this that. And we can also save this to a CSV file for a report. Same as before, we can have a preview of what that looks like. So we can sort of press preview and it's going to load all the data up on screen for us. And you can see for each of my drill holes, we've got 2 points that get flagged for each of my domain triangulations downhole. Very simple, but quite a handy thing for that. So when we're happy with that, we can just save and run that. And if I hide my triangulations, you can see for each of those points, you get the drill hole ID as the point or the object name. And then we get these metadata attributes which tell us which triangulation it intersected and at what depth downhole it intersected. So that'll obviously change for each of the points. And obviously we made our CSV file. So if we open that in the CSV editor, we get, again, for each triangulation, you get a separate row. You get the intersection. Again, if that particular triangulation has more than one intersection with that hole, you get an extra column, so you get 2 intersections. So we know that if we're logging UGD 0001, we should look out for TQ1 between 39 meters and 52.5 meters downhole. Well, that's it for the last video in this Drill Hole Planning with Dan series. Thanks for watching, and I hope you get a lot of value from these tools when designing your drill programs.